Let's talk about normal distribution. The data is continuous. It has a symmetric bell-shaped curve, like this diagram. Mean, mode, and median are equal in the center. And also try to remember these three numbers. X follows normal distribution. Mu is mean. Sigma is a standard deviation. Sigma squared here. No PDF because the data is continuous. We can figure out the following probability by graphing calculator. Since the data is continuous, probability of x less than or equal to a equals probability of x less than a. Normally we use negative 10 to the 99th power for negative infinity, 10 to the 99th power for positive infinity. If you are given the probability of x less than or equal to a, you can figure out a by using inverse norm. Area always means the area under the curve when x less than or equal to a. You have to change the probability into probability of x less than or equal to a first in order to figure out this a. For example, if P of x greater than b equals q, if you want to figure out this b, you have to figure out probability of x less than or equal to b equals 1 minus q. Then b equals inverse norm 1 minus q mu sigma. Question 1. Consider the following graphs of normal distributions. In the following table, write down the letter of corresponding graph next to the given mean and standard deviation. This is a normal distribution curve. You could say it's a symmetric and a bell-shaped curve. The probability between mu minus 3 sigma and mu plus 3 sigma is 99.7%. This will give you a clue on how to work this out. Check mean first. Mean is the symmetric line. -2. Only graph C with the mean -2. So this is a graph C. Second one, mu equals 0 and sigma equals 1.307. In graph A, mu is 0. Mu plus 3 sigma is 5. So 5 over 3 can be estimated as sigma equals 1.7. Graph B. For graph D, mu equals 0. Estimate 2 as mu plus 3 sigma. So 2 over 3 can be estimated as sigma equals 0.7. Then the second one is A. The third one is D. Let's go to B. At an airport, the weight of suitcases in kilograms were measured. The weights are normally distributed with a mean of 20 kilograms and a standard deviation 3.5 kilogram, which means mu equals 20, sigma equals 3.5. Find the probability that a suitcase weighs less than 15 kilograms. 2 marks for this question. 1 mark for method, the other for the accuracy of your answer. Interpreting the question is counted as a method mark. Basically, we are looking for probability. Since in this question, the variable is not defined, we will use a general random variable x less than 15 equals. Go to graphing calculator. Second distribution, normal CDF. Lower bound is a negative infinity. This is a default. Upper bound is 15. Mean is 20. Standard deviation is 3.5. Enter. Answer is 0.0766. You can write down the answer directly, 0.0766. If you want to, you can show the work normal CDF, negative 10 to the 99th power, 15, 20, 3.5. This is optional. Let's go to C. Any suitcase that weighs more than kilogram is identified as excess baggage. 19.6% of the suitcases at this airport are identified as excess baggage. Find the value of K. According to this given information, we know probability of X greater than K equals 0.196. Change this percentage into decimal. We are looking for this K. You got to use inverse normal distribution. Suppose this is a K. Shaded area is 0.196. So probability of X less than or equal to K equals 1 minus 0.196. And K equals, using inverse norm distribution, inverse norm. Remember, for the area in the graphing calculator is always a probability of X less than or equal to K. So I will put 1 minus 0.196. Mean is 20. Standard deviation is 3.5. Then enter. K equals 23.0. You can write down the answer directly. Or if you want to, you can write down this inverse norm. 1 minus 0.196, 23.5. Let's go to D. A random variable Z is normally distributed with a mean 0 and standard deviation 1. It is known that probability of Z less than negative 1.6 is A. Probability of Z greater than 2.4 is B. This is shown in the following diagram. Find the probability of Z greater than negative 1.6 less than 2.4. Write down your answer in terms of A and B. The area under the curve is 1. Therefore, probability of Z greater than negative 1.6 less than 2.4 equals 1 minus A minus B. Let's go to E. Given that Z greater than negative 1.6, find the probability that Z less than 2.4. Write down your answer in terms of A and B. Since given that this is a conditional probability, so we can write down probability Z less than 2.4, given that Z greater than negative 1.6. Then we will use this formula. Probability of A intersection B. This is A. This is B. You will get Z greater than negative 1.6 less than 2.4 over probability of B, probability of Z greater than negative 1.6. Numerator we already figured out in D, 1 minus A minus B. Probability of Z greater than negative 1.6 will be 1 minus A.